As the Sun approaches, a small planet hides secrets. Small, hot Mercury has been a mystery for years, but now space robots have discovered some unusual surprises. They say they have found a diamond on the hottest planet. This is the beginning. In Mercury, everything is wrong. Too much, too much. Why is it different from other planets? And what else does Mercury hide? Mercury, the smallest planet in the solar system, is a fascinating subject for astronomers and space enthusiasts. Hidden from view for centuries, the mysterious land only began to reveal its secrets as space exploration gained popularity. The journey to discover the mysterious planet Mercury began with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe in 2004. Mariner 10, the first spacecraft to visit to Mercury, we first discovered this complex world. During the flyby, it will capture images that show the Earth is full of strange craters and bulges similar to our moon. The mission discovered that Mercury has a rocky exterior with a surprising magnetic field and a larger core than expected. These findings challenge previous scientists' assumptions about Mercury's composition. Messenger, Mercury's surface, space environment, geochemistry, and range, launched 31 years after Mariner 10, advanced our understanding of Mercury. Unlike its predecessor, Messenger was designed to enter Mercury's orbit, allowing for a comprehensive study of the planet. 200,000 images were taken by Messenger during the mission, revealing never-before-seen areas of Mercury. One of Messenger's most exciting discoveries was the discovery of high levels of magnesium and manganese on Mercury's dark side. This has raised questions about the mechanisms involved in these suicides. In addition, the mission showed that Mercury's magnetic field is very strong in its northern regions, which is remarkable compared to other planets. These findings led scientists to realize that Mercury's interior structure and composition are very different from what they first thought. On most planets like Earth, magnetic fields are created by the movement of liquid iron in the core. However, Mercury's internal structure leads to unusual magnetic behavior. But what happens when Mercury leaves Earth? It's not just the holes and dents, but the most important surface features. During the day, Mercury's temperature reaches 430 degrees Celsius 860 degrees Fahrenheit, hot enough to melt lead. At night, the temperature drops to 180 degrees Celsius minus 292 degrees Fahrenheit. The large temperature variation is due to the thinness of the Mercury, which does little to regulate temperature or retain heat. Despite these shortcomings, recent studies have revealed some surprising features on Mercury's surface. In 2012, Messenger data showed evidence of volcanic activity on Mercury, including pyroclastic deposits from explosive volcanoes. This discovery challenged the old belief that Mercury was dead. Interestingly, in 2012, scientists announced the discovery of water ice in some of Mercury's polar craters. These shadow regions are cold enough to hold water ice, even on a planet close to the Sun. The discovery raises new questions about the potential for simple life forms on Mercury. Could aliens, like those found in harsh environments on Earth, live in these icy places? The latest mission to Mercury, Bepi Colombo, launched in 2018 in collaboration with the European Space Agency and the Japan Aerospace Exploration Agency, is scheduled to reach Mercury in 2025. This mission promises to provide detailed information on Mercury's surface, including its chemical composition and Earth's history. From its mysterious magnetic field to the existence of water ice, Mercury continues to amaze. But what's about to explore next will force you to do two things. What about a planet near the Sun that has a year shorter than its Sun, a number less than a day? When we think of the planets, we think of them as rotating on the same axis every day, orbiting the Sun in a year. But Mercury breaks this trap in a very dramatic way. In this small world that is scorched by the Sun, the year is shorter than the Sun. Here's a breakdown. Mercury only takes 88 days to orbit the Sun. This speed would make Mercury's age shorter than ours. But here's the cool thing. A day on Mercury, or a full revolution on its axis, takes 176 Earth days. In fact, a year on Mercury is only half a day long. This unusual situation leads to more unusual situations. If you were standing on the surface of Mercury, you would see the sun rise, grow in the sky, and slowly move through the sky. At one point the day ends, it retreats for a moment, and then returns to its original destination. This strange dance occurs because Mercury's rotation cannot keep up with its orbital speed. But why does Mercury rotate so slowly? Scientists think it's because of something called tidal locking. Over billions of years, the sun's pull slowed Mercury's rotation. But unlike our moon, which is completely locked to Earth, Mercury is in a 3:2 orbital resonance. Normally, the sun goes around 3 times every second cycle. This day and night cycle has significant effects on Mercury's surface. The side facing the sun is baked under intense heat for months at a time, while the side facing the night stays in the cold darkness for long periods of time. This causes some of the most dramatic temperature changes in the solar system. As for Mercury's atmosphere or not, remember that the lower part of Mercury is called the exosphere. This thin layer of air is lost in space and filled by various processes. The solar wind, radioactive decay, and meteorite impacts keep Mercury thin. Recent discoveries have revealed amazing features of the planet Mercury. In 2020, researchers using data from the Messenger spacecraft discovered that Mercury's exosphere contains more water vapor than previously thought. This water vapor is thought to form when hydrogen from the solar wind combines with oxygen in Mercury's surface rocks. Another interesting aspect of Mercury's short year and long day is its effect on the planet's magnetic field. Despite its small size and slow rotation, Mercury has a magnetic field that surprised scientists when it was first discovered. Recent studies suggest that Mercury's magnetic field is created by a unique dynamo effect in its liquid metal core, driven by orbital conditions and the planet's rotation. Although this magnetic field is weaker than Earth's, it plays an important role in protecting Mercury's surface from the strong solar wind. Otherwise, the solar wind would quickly take up Mercury's atmosphere. Mercury's surface has areas called hot poles, and the sun is sometimes in the sky. These warm poles experience the most intense heat in the world. On the other hand, there are places near the poles of Mercury that do not see the sun. These sheltered areas are exactly where scientists have found evidence of water ice. But how can I survive on a planet so close to the sun? This is all thanks to the unique orbit and rotation of Mercury. The holes in the permanent shadow near Mercury's poles do not reach the sun directly, and are very cold even when the surrounding areas are baked by the sun's heat. This discovery led scientists to wonder if other strange substances, such as organic compounds, could be stored in these cold traps. Mercury's short year and long day are associated with the study of the planet. Because of Mercury's fast orbit around the sun, it is difficult for spacecraft to reach it. They had to use complex maneuvers, including multiple flybys of Venus and Mercury itself, to slow down the rate of rotation around the planet. On its way to Mercury, the Bepi-Colombo mission will use these powerful aids to adjust its speed and trajectory. The spacecraft was launched in 2018 and will not enter Mercury orbit until 2025 after completing 9 flights. Once in orbit, Bepi-Colombo will face another challenge related to Mercury's unusual day-night cycle. The spacecraft absorbed the intense heat from Mercury during the day and conserved energy through the long, cold nights. This delicate balance is critical to the success of the mission and reflects the unique properties created by Mercury's unique spin and orbit. Recent computer simulations have provided new insight into how Mercury ended up at its current rotation rate. These models show that Mercury is rotating faster, but has slowed down due to a combination of the sun's influence and collisions with large asteroids. This research will help us understand not only the history of Mercury, but also how the other planets in the solar system evolved. As we continue to study Mercury, new questions arise. How does the planet's core stay liquid despite the long, cold nights? What role did Mercury's unusual orbit play in the formation of Earth? These questions remind us that even within our own solar system, there are still many mysteries to be discovered. Mercury's unique properties challenge our understanding of planetary formation and evolution, prompting us to expand our theories and explore new possibilities. What other crazy things does Mercury hide under its open facade? A small planet with many secrets. Mercury, the smallest planet in the solar system, packs a lot of secrets into its tiny shell. Despite its size, Mercury continues to fascinate scientists with its unique and surprising properties.